kicked me. And then so I was like, okay, listen, you need to be scared of me, not trying to take me down. So then I was like, all right, so I went after her, and now she's
Bully. Big bully. Don't scare the freshmen.
Yeah, the freshmen should be scared of me, not think that they can
All right.
take me down.
All right.
You didn't think that, Kate. You got it from behind. No, she kicked me down. She did not fall. I was in front of her and she kicked me down. The girl though fell to the other side.
We're acting like you're a victim.
I'm not. What? I am.
Because now you got some kid who's scared of you, crying himself to sleep. Yeah, you're our bully. All right.
I'm not a bully.
We love you, Kate. Beat someone up. We'll keep you around. All right, tangent.
Kate beat up for freshman.
What questions do we have off the homework work? 16. Yay.
Are you gonna be at the game tonight, Mr. Syrup?
Yeah, buddy.
I'll see you there, buddy.
Yeah, man.
Way all dressed up.
You want me to be all dressed up? Sure, I'll get you one.
Yeah, it's like Western epic
Is this the right one? Am I looking at the right one?
Yeah. It's all you, Mr. Syrup. I left my water bottle in my car, so I need to get water.
All right. So is this the one you asked for? I forgot who you were going to ask for it. Yeah, cool. It's a cosine graph. Yay. All right, so let's graph it. First thing I'm going to do is we're just going to put our traditional marks, and then we can move things if needed. -1. Okay, so our regular cosine graph is this. Agree? That's our regular cosine graph. Yes? Mm-hmm. So let's make this line right here is going to be what now? -1. So if this is -1, this is now 0. So this is where my x-axis actually is at now. And then this is -2. Got it? So my center line is at -1. Now it's going to be triple tall. So what's 3 above -1? Well, I got 0, I got 1, I got 2. It's 2. Cool. So now I'm going to change this because this is a 3. I'm going to go all the way up to 2 from -1. And then I'm going to go down to -4. Okay, so far I've taken care of this part because I changed my center line. Now I took care of this part on my labeling. What does this do? What does that do?
moves it to the left.
Left. How much?
Pi over 4.
So everything moves to the left. So I'm going to subtract pi over 4 from this. Subtract pi over 4 from this. Subtract pi over 4. Pi over 4. Pi over 4. Pi over 4. All right, let's do the math. So this is no longer my y-axis. My y-axis is now right here. So this is the point pi over 4. That's going to be 3 pi over 4. So let's get rid of that. That's going to be, oh wait, I screwed up. That's just pi over 4 here. And then this is 3 pi over 4. And then if I subtract pi over 4 from that, I get 6 over 4. So that's 5 pi over 4. So don't worry about that. Don't worry about that. And do the subtracting here. That's going to give me 8 pi over 4. So that's 7 pi over 4. Cool. So I'd be looking for these to be correctly identified. Pi over 4 and there. And then make sure these are appropriately labeled. Okay. Cool. Mm-hmm. That's number 16. What else did you see on this assignment that you'd like to What? 2?
Yep.
All right. Number 2. So we want the graph. Is that what it is? So okay, so it goes between pi over 2 and negative pi over 2. So our period is just pi. So the period, if we had to deal with this, is just going to be pi because that's the distance between one iteration. It looks like because of this, we have a downward shift of 1. So I got a negative 1 here. It's the same thing. Oh, but it's going backwards. It's going backwards. And this is left 1, up 1. So that's going to be a negative. So I have to have a negative out front. So I get y equals negative tangent x minus 1. The negative flip-flops the tangent to the different, going from left to right versus it rises to the left, it falls to the right. Is what flips it around. Cool. Anything else? 17.
The word problem.
Yay! Story time. It's not the kind of story I tell, but hey, still a story. The paddle wheel of the SS Beaver was 13 feet in diameter, revolves 30 times per minute with traveling at top speed. Using the speed starting from any point at the very top of the wheel, write a model for HT at the end of the paddle relative to the water surface as the function of time in minutes. Assume the paddle is 2 feet below the water surface at its lowest point. Okay. So you got this paddle wheel. Let's just pretend I can draw a center thing. And here's the water line. They tell us that this is a 13-foot diameter. It's 2 feet below the water. Okay, and it goes around at 30 times per minute. So that means every 2 seconds it goes all the way around. If I can spell seconds. And then 2 feet above. Okay, got that. So the water underneath is not a huge part of this problem. So I would say if we were to do a cosine graph off this, do they want anything in paddle wheel using the speed term? Write a function. So we can do sine or cosine, doesn't matter. All right, so paddle wheel's going round and round. So let's go with sine. Being I have a radius of 13, I'm going to put a 13 there. Yeah, that's right. And then time in seconds, 2 seconds. So 2 seconds. So slap this in the middle. So I got 0. No, I don't want to do it that way. What's 2 seconds going to do for us? So I'm going to divide by 30. Okay. So that's going to be revolution pi over 30 theta. And then plus, I guess we can go plus the 11. I'd be happy with that. You'd make it as cosine, it's still going to be the same. And it said anywhere on the wheel, so if you change sine versus cosine, it's still just an up and down type of thing. Plus 11 came from this distance here. Cool. What else? Let's not worry about that one. You will not see that one on a quiz. Cool? We good? Happy? All right, make sure your names are on those, please. Pass it on forward. If you pass anything else forward, that'd be awesome as well.
Grant just never shows up.
Alright. Sorry, I got like 4 things coming in. Regards to my grades.
Someone's watching my videos. He's been getting emails that has been watched.
Really?
I watch it.
I'm serious. On what?
I watch
I know he's been on.
There you go, bro.
This is the special. Right there. Special.
But it's lunchtime of the day.
I'll be right back.
Don't worry, I'm that too.
Unit right now? No. So there'll be some review, but then we will start the new next unit, which is not going to be tested on Friday.
I just threw my back.
Oh no.
I'm sorry, I'm just trying to say something. Everyone got a copy of the review notes?
Wait, after the unit, are we done with trigonometry?
Yeah.
I just threw it over.
It's quick.
Nice. They don't want you to get triggered.
Alright, let's see. Trig review. So, everyone's okay with these if I just go through these quickly? So that's 0, that's pi, that's 2 pi. That's pi over 2. That's 3 pi over 4. So sine has a max and a min. If that's a 1, that's a negative 1. So our sine curve looks like that. Yay. Cosine curve does the same thing, except it's shifted by pi over 2, pi, 3 pi over 2, and 2 pi. So cosine starts at a max and goes to a 0, then a min, then a 0, then a max. So again, sine and cosine are just a phase shift of 90 degrees different. And then tangent's the goofy one. So we have to realize that goes between negative pi halves and pi halves, which those are both asymptotes. And if that's pi fourths, which is 45 degrees, that's 1. That's what your tangent graph looks like when it repeats. Sam, did you not give?
Oh, my bad.
It is.
Your fault, Sam.
Did you guys get Sam? Well, you only got one. Sam is out of control. Starts playing with matches. Watch out.
Sam, what's your last name?
North, my dude. North. Like the direction.
I am.
I was like, when I saw his name,
Sam, I am.
that's a sick name.
Sam, I am. That rolls off your tongue better. I like that.
Sam North.
Sam I am is now Sam North.
Sam, I am.
Nice. I mean,
All right.
I made the green eggs and ham.
I will not eat them here or there. I will not eat them anywhere. All right.
What's on?
All right. Can I move on? We good? Yay? Moving. Okay. So the tangent graph. Take a look. The midline right here is 1. The amplitude still looks like that's 1. The period is still a distance of pi because from negative pi halves to pi halves. Or from, I take that back. I can't see this. That it says pi halves, and that's 3 pi over 2. So my period actually takes place. 3 pi over 2 minus pi over 2 is 2 pi over 2, which is still pi. Oh yeah, it's still pi. But we have a shift. We have a shift to the right on this one. And it looks like it shifted right pi fourths. All right, so my equation here is going to be y equals tangent theta minus pi fourths because it shifted right 1 iteration. Cool? Too much talking back yonder. Midline here, 1. Amplitude here. It's going up and down 1. Period. Goes from 0 to 2 pi. Yay, life is good. The equation, it looks like it's going to be a negative sine graph. Negative sine x, and then plus 1. Pretty simple. This one goes, oh shoot, that's still blurry. Is that 7 pi over 2, I think? Is that right? So that's then what? 4 pi? I think that's what that says, I think. Of course, mine's bigger than your paper has, so you guys, I can tell you anything. All right, so let's say midline is 0. It's going to go up 1. The period is going to go 1 iteration to 4 pi. Pi!
Thank you so
Yay! That's 7th period.
That's 7. Yep.
Ooh, let's see.
And they have to turn it in at the end of class.
Turn this in. Ooh, hey, that's cool. Look at this, guys. So in differential equations, she has an equation here of 5 cosine 4t, and the equation below it as a determinant, or as a matrix, is 3 cosine 4t minus 4 sine 4t. So whenever you're going to have to use this stuff again in life, in differential equations.
What if we don't?
No, if you can make it through algebra 2, you can take Giphy Q.
No. You can.
Wait,
Trust.
Thank you, Mr. Stirrup.
Ms. Lewis, you got it.
would the answer be 4 pi over 6?
Ooh, we're on this one, right?
Oh, no, not that one. I was talking about what you had said.
Oh, I have no idea. You'd have to ask Ms. Lewis.
Yeah, it is. Oh, thanks.
All right. Hey, this looks like a negative cosine. Agree? Negative cosine, same amplitude. 2 pi. So this is happening half as often. It's halfway there, so I get half x. Done? Good. Yay. What did I do wrong?
Your S is not good for me. It's weird.
I know. Because I tripped and fell, and then I opened the door that made the alarm, and someone yelled at me, and it wasn't even a teacher, or a dean, or administrator. It was a student. What's up, man? You can't do. I'm like, oh, dude.
You knocked the door open?
No, but it sounds kind of funny.
Is there a plus 1 in front of on question 1? Plus 1 because the midline is 1 on the outside.
Oh yeah. Plus 1. Good call. So that one's got a plus 1 to it. Kind of looks like a subscript, and I apologize.
If someone happened to prop that door open, what would happen?
The alarm would keep
You
going.
die.
Sure.
No one's dying.
I had suggested it'd be fun every time the alarm goes off, tear gas goes right in your face, so you have people like, ah! I think that'd be funny, but they're like, no, we can't do that. I'm like, why not?
They got tasers coming out.
You know, because people might get upset if they get maced. I'm like, so what? All right, my midline here is -1. Amplitude, if that's my midline, looks like it's going to be 2. My period is taking place still between 0 and 2 pi, so we're happy here. And my equation, we're starting at a max, so it's definitely a cosine. It's a cosine, and it's twice as tall, right?
Yep.
X, and then our midline shifted down 1. Done. Yay!
Nice.
Your backpack, what? All right, midline here looks like -2 because you left all your homework at home. Your amplitude goes up and down 1. Your period here goes, that's 4 pi. So the period takes place every 4 pi. So my equation is going to be its sine, because it starts at a midline of, takes that much longer. So it got from 0 to 2 pi in half the time.
Nice.
Half theta. We'll make a theta now. Can I interchange theta and x? Oh, and then it's -2. Yay. Ooh, look at this fancy one. Man, we have.
Like a parabola.
It is a parabola just for you, Sam. So the HK value is 1, -2. Actually, it's pi/4 -2. If you really want to go there. All right. I don't know. I'm moving on. So midline 0, amplitude 2, period, pi halves. Yay. Excuse me. Equation got there twice as fast. So it's going to be 2 cosine of 2 theta. The reason it's 2 theta is, no wait, I take it back.
No, it's
I take it back. It's not 2 theta. What is it? It's 4 theta. 4 theta. Because you'd have 4 of these iterations between 0 and 2 pi. So that's a 4 right there. I know it looks like it really well. I'm writing as well as blurry as this is. So what the hell's wrong with stirrup today? I don't know.
How was your Valentine's Day? Was it good?
You know what? This morning I ate that chocolate apple you gave me.
Actually?
And now I'm not feeling so good.
Really?
I ate the whole thing like 20 minutes ago. It was awesome. Thanks, man.
Yeah. But did you go to dinner with your wife?
No, she had to teach college last night.
That's tough.
Yeah. So my youngest daughter and I, we had dinner together. My oldest daughter was at swimming.
Oh.
It's all right. Don't feel sorry for me. Life's all right.
You still got chocolate.
Yeah, I like chocolate.
I like chocolate.
Although I feel like I might throw up, but you know, if I barf, get your phones out. I'll warn you for an exam, and I'll pick an individual student and barf on them. That'd be awesome.
Just like on the test.
Just like, hey, where'd Big Red go? Where's the gypsy?
I didn't see him.
All right. Whoa. No. Where's the other gypsy? Did you guys lock him outside again?
Yeah.
Okay.
He opened the exit door.
All right. I think I'm kind of done working out all of these so far. Okay, finally we get to some graphing. All right, so negative sign. So that means that this bad boy is going to do this. So let's figure it. It's just one iteration. Pi over 2. 3 pi over 2. 2 pi. Midline 1, amplitude 1, period, 2 pi. Yay. This one has a midline. This is 2, so this goes up to 3, down to 1. Cosine goes here, to here, to here, to here, to here. Yay. Okay, midline on this one is 2. Our amplitude is 1 because it's only on 1 above because there's only 1 out front. And then that goes out to 2 pi. Giddy up. 2 cosine. So this is twice as tall. So midline 0, amplitude 2, period still 2 pi. So that's 2, that's negative 2. Cosine starts here, then goes to here, then goes to here, here, here. Happy day. Good.
I completely understood that.
I hope so. I've been teaching it all week. I just haven't been paying attention.
Me neither.
I'm like most people. I just like to hear myself talk, but I don't listen. All right. Midline negative 1, amplitude is 1. Remember, amplitude's always positive. Period. Looks like it's going to still go to 2 pi. So cosine, we're going negative, so it's going to be here to here to here to here to here. That's the 2 pi. So it went upside down, and this line here was a negative 1, and so this would be at 0. That's actually my axis now, and that's negative 2. Yes. So that's going to be 0. That's going to be pi over 8. That's going to be pi over pi over 4. Pi over 2 is pi over 4. That's 3 pi over 4. And now that's at pi. It's going to happen twice as often. And this is my center line here. That's 1. That's 2. That's negative 0. So here is our graph. Oh, that was bad. There we go. So midline 1, amplitude 1.
Thanks, yeah.
Period. What do we got?
It wants some water?
2 pi. It's pi. But close. He threw water.
50-50%.
50-50?
50-50, it's 2 pi every time.
Better than half the other people here. Alright, 1, 1, period here. It's, what are you giving me now? Absent?
Absent.
No. We can recycle it. You can put that in the recycle bin as you rock. Alright, moving on. I want to get through this. Moving on.
J.
Not going to see that tough. Alright. We did this one yesterday, very similar, so we can figure that out. I'm not going to test you on that one. I want to get to this one. Is this one okay?
Yeah.
Okay. If you have a graphic calculator, get it out. If not, you can just sit and chill and watch if that's okay. Still with me?
Yeah, I got one.
That's what I do in all my classes. I just sit and chill.
Sit and chill.
I got a note calculator.
So this question you will more than likely see as a bonus question, okay? So I'm going to walk through the calculator like we've never used it before. Good? Blessing you.
Thank you.
All right. So you turn it on. Yay.
Okay, now what?
Just hit second mode, clear things out. Go to y equals. If there's nothing there, great. Okay, but you do want to, bless you, you do want to turn your plot on. So I'm going to do that. So now that is on. Okay. Is that okay? Yeah. Everybody.
Wait,
Hop.
plot on?
Yeah, turn it on because we're going to plot some points.
Where's the problem I want to do? It's on the back page.
Man, this calculator is like a super going. It has 3
Alright.
plots.
So, alright, so I'm going to go stat, edit. Still with me? If you have things plotted, you go to the top, you hit clear, then down arrow. Don't hit delete, please. Hit clear. Still with me? And it looks like we go 1, 2, 3. Oh man, we're skipping days. We got 1, 2, 3, 5, 6, 7, 8, 10.
4.
I know, but I'm looking at the date on the back. It's not there, right?
It's not making this up, man.
It's not making this up. Alright, then we got 14, 20, 12, 04, 10, 26.
Oh, 14, 20 is one number.
It's 260, 78.
What's the second number?
It's on the back page.
Yeah, it'd take a lot of work to do that.
Look over your packet.
Got it.
Got it. Alright. I got 1, 14, 20. Good. 2, 12, 04. Yes. 3, 10, 26. 5, 260. 6, 78. 7, 12. 8, 31.
There we go.
10, 450.
Alright, I'm ready.
12, 1287. Are we good so far?
Yeah.
Okay. So if I just hit graph right now, I'm not seeing nothing.
What's that?
So what should we do so we can see our data?
Zoom fit.
Zoom. I'd hit zoom stat. The zoom stat is my data.
Nice.
So that's what the data looks like so far. You still with me?
Yeah, sure.
Okay. Where do we find the equation that this goes with?
Math.
We're going to go to stat, what?
Calc.
Calc. And the only regression they have with trig is sine regression. So we have to go find the sine regression. If you go down, that's manual
C.
fit. So it's letter C. Sine regression. Iterations 3 sounds good. List 1, list 2, I like it. So go down and hit calculate. So this is my sine curve. So you have A, BX plus C plus D. Hey friends, I want to warn you about one thing up here. Okay, notice that they have BX plus C. How you will see it later, next year. This B is actually factored out front here, so it's sine B parentheses X, or theta, plus C over B. So just be aware of that. But this is our equation that works. So we have an amplitude of 749.6 roughly. We have a phase shift of 712, went up. So then once we have this here, how do we look at what our graph looks like on our page? Or do we even need that? It says here, Okay, for any given day, the number of degrees that the average temperature is below 65 is called degree days for that day. Okay. I don't know why. Figure used to calculate how much is spent heating the table gives the total number of T of degree days for each month in that Iowa town. Those idiots out wandering around, I'll tell you. With T equals 1 representing January, find the model of the date rounding your values to the nearest hundredth, and then use your model to estimate the number of degree days for April. Okay, so we do have to do this. All right, ready? So if I hit y equals, my graph didn't show up. Where's my graph at? Where do I find my line of best fit, my sign regression? Vars, thank you. Where? Statistics. Then where? Equation, regression equation. So now it plots that in there. If I hit graph, there's my sine curve. Okay, so they want our model to estimate the number of days for April. So January, February, March, April. April's the 4th month, agreed?
Yep.
So I want to calculate a value on the 4th day. So 1, 2, 3, 4. So it's like up here someplace. Agree? So I'm going to go second, calculate. I want to find a value. 4 is April. Boom. Looks like they have roughly 630 of those kind of days.
Nice.
Or hours or minutes or. That's it.
Hey, so unrelated, but why do they use degrees and temperature and like math at the same time?
What?
It's a different thing.
Okay.
They didn't come up with the relative thing of temperature for quite some time. I mean, what was discovered is honestly by looking at mercury, and they realized when it was warmer, the mercury had expanded. When it was colder, it had contracted. That's why you put mercury in thermometers. And then it was fun to break the thermometers open and play with that, but it screws up the hemoglobin in your system, so it's toxic. So then they realized, let's not put mercury in thermometers anymore because kids like playing with liquid metal that's not hot. So degrees that you're dealing with in go to unit circle is going to be different than the degrees that we're talking about as far as Fahrenheit, Celsius, Kelvin, whatever scale you're on. That's it.
Cool.
Yeah.
So you go second calculate, then what?
What did the second calculate to do what? I'm sorry.
So you go like vars stats, equation, and then regular.
Oh, okay. So you're on your graph. So you're going to go second, trace.
Yeah.
You're going to go to find a value, which is 1.
Okay.
And then you plug the 4 in.
Okay.
It gives you the y component of it. All right. So Riley wanted a story.
Yeah.
Yeah. All right. Here's a little story. So this happened. Oh, sheesh. This was 1995. And we were up here. My friends and I, we were up here. We were staying up in Silverthorne, and at the time they had these really great 4-packs of ski passes you could get. So you get this 4-pack. It was good for Breckenridge, Keystone, A Basin, and someplace else up there. I think it was Copper Mountain. And so one of the days we were skiing, it was like the biggest snowflakes, dumping snow like no other. And my buddy Todd and I were skiing up in Breck, and I have no idea what run I'm coming down. Couldn't see much further than 4 or 5 feet in front of me. And I mean, it is a day that I wish I had pow skis on because I was like up to my waist. So we get down the run and we're like, dude, that was so awesome, but there is nobody out. I mean, it is just whiteout conditions. And we look and the lift is still on, but there's nobody at the lift. Like no operator or anything. So Todd and I are like, sweet. So we like totally cut in line because there's no one in line. You know, like we went under barriers and stuff, got on the lift, and we're riding up the lift. And now we're like this, like, oh my gosh, it's so cold. And we look like snowmen like within 5 minutes. So all of a sudden, as we're coming up the lift, I don't know, we're about 2/3 of the way up. The lift goes,
Oh, there's a movie like that. It's
and Todd and I are looking at each other going, not sure what's going on, but we're just chilling. Now, this is before people have cell phones. And it is snowing like no other. Wind's blowing. Lift is rocking back and forth. And so we're sitting there and we're looking down and everything's white. And we're wiping our goggles. Everything's still white. I'm like, so, you know, I did what every red-blooded American does in that situation. I put a big old dip of Copenhagen in. And so I could spit in it and see how far it down was. So all of a sudden, well, hey, you know,
That's true.
just saying. So anyhow, we're up there, and it is now a long period of time that has taken place. Right. And then we realized that the guy who was at the very top is now skiing down.
Oh.
And so we see him like, hey! And like it's totally snowing, so like from me to you is about how far we can scream. He finally stops under us. He's looking around, picks up his goggles, looking around. I'm like, we're up here. And he goes, lift's closed. I'm like, no, we're on it. So
Did he turn back on?
yeah, he did. Got on his radio and he's like, I'm on lift, whatever. And so they turned it back on, and we got off, and it was fun.
Get this back down again?
Huh?
I'm sure they were so close.
Well, the thing was, there's no one up at the top anymore, so there was no one to really yell at us. And it took us a while to get down that mountain because, my goodness, it was dumping like crazy. I mean, we're talking like a foot an hour of snow. It was ridiculous.
You should have just jumped off the lift.
Well, it was enough powder, I probably could have handled it. But I wasn't quite. It was also one of those I couldn't see necessarily how high up I was. 'Cause that's how wide out it was. But I didn't know. Well, let's face it. If the people at the lift have the lift still on, you better as well sit there until you turn it off. And just freeze, yes. And don't allow morons like Chris Stirrup and Todd Frazier to get on the lift if it's closing.
Why
Huh?
that happened to you?
Why?
Yeah, why did it happen?
Because we went past the barriers that they had pulled, you know, because it's like that door out there. That door's only for the honest people not to use it. Everyone else is like, I'm going to use it, right?
That's why it's
If the whole
totally
class
what
goes down,
today.
then normally you
Yeah, that's what I was saying. If we all go out there, they can't spend all.
That's what I was saying yesterday.
And you know what? If they do suspend us, man, we get to go to Red Robin for
Yeah.
lunch. We can have donuts.
That's on me if they suspend.
Go to
us.
Denny's. It'd be the best day ever.
Yeah.
So sound good for everybody?
Send us now, we'll have to take pictures.